Hello everyone, my name is Clovis BK from Olga Book. In today's video, we are going to be answering Chemistry Advanced Level, paper number 1, June 2023, Cameroon General Certificate of Education. We are going to answer the first 25 questions, and if you encounter any problems along the line, feel free to write down any problem in the comment section. We will try as much as possible to respond to you. So let's get right into the video. Question number 1. Give the name of the instrument used to determine the structure of crystals. So crystal structure determination is by X-ray crystallography, which is the process involved, and the instrument we need for that is the X-ray goniometer. So this is the diagram of the X-ray goniometer, where X-rays are being incident onto a crystal and are being reflected, and the crystal is then analyzed and its structure determined. So our correct option is B, X-ray goniometer. Question number 2. Below are some properties of chlorine, bromine, and their compounds. Which property has a smaller value for chlorine than bromine? So our point of interest is to get an option where the value is smaller for chlorine than for bromine. So our option A says bond strength of hydrogen-halogen bond. So with respect to chlorine, HCl and HBr, down the group, bond length increases and becomes weaker. So therefore, the bond strength of hydrogen chloride is definitely going to be greater than the bond strength of hydrogen bromide. Therefore, option A cannot be true. Option B, strength of van der Waals forces between the molecules of the elements. So we know that for fluorine, chlorine, bromine, iodine, and astatine, the van der Waals strength increases down the group as the molecular mass also increases. Therefore, we have option B to be correct. C talks about first ionization energy, which would definitely be decreasing down the group, making it incorrect. D, the solubility of silver halide in aqueous solution or in aqueous ammonia. So the solubility will decrease from chlorine to iodine. Therefore, our correct option is B, the strength of van der Waals between them. So van der Waals strength will be increasing as we move down the group, making option B to be correct. Question number 3. Given the following half equations, we have the chromium half equation and copper half equation, and each with its corresponding electrode potential value. Calculate the EMF of the cell formed when the two half cells are coupled. So in the calculation of EMF, the EMF of the cell is simply going to be equal to the larger EMF, which is positive 0.34, minus the lower EMF, which is minus 0.41 volt. So we're going to have 0.34 minus 0.41. So our E cell is going to be equal to 0.75 positive volt. So it should be noted that the half cell with the higher EMF is the cathode, while that with the lower EMF is the anode. Therefore, the E cell calculation is the EMF of the cathode minus the EMF of the anode. So our correct option is A. Question number 4. The radioactive decay of nickel has a half-life of 120 days. How long will it take for 1.2 grams of nickel to reduce to 0.30 grams? So we have been given initial amount, we'll call it N0, which is equal to 1.2. After a certain time T, which we do not know, we have a new amount N at that time T, which is 0.30 grams. So using the decay equation, N equal to N0 e to the minus lambda t, where lambda is equal to ln 2 divided by the half-life. So we know N, we know N naught. What we do not know is T. So we're going to make T the subject of the formula. So to remove this exponential sign, we'll take the natural logarithm on both sides. We're going to have ln N equal to ln N naught plus minus lambda T. Simplifying will give us minus lambda T to be equal to ln N divided by N naught. So T is going to be equal to ln N divided by N naught, all that over lambda, which of course is going to be negative here. So when we substitute the values given above, our time T is going to equal 240 days, making our answer to be equal to C. Question number 5. Which reagent is used to distinguish between propan-1-ol and propan-2-ol? So propan-1-ol is a primary alcohol, while propan-2-ol is a secondary alcohol. And the primary and secondary alcohols can be distinguished using the Lucas reagent. And the Lucas reagent is zinc chloride in concentrated hydrochloric acid, where secondary alcohols will form cloudiness after about 5 minutes, while there will be no significant change with primary alcohols. So making our answer to be D. Question 6. Which of the terms below permits the use of +4 oxidation states by group 4 elements in the formation of compounds? So the correct answer is C. Hybridization allows group 4 elements to form compounds with a +4 oxidation state by promoting the mixing of atomic orbitals to form hybrid orbitals. This allows for the formation of 4 covalent bonds, resulting in a +4 oxidation state. So hybridization permits the +4 oxidation state formation, while inert pair effect, which brings about the reluctance of the outer s electrons to take part in bonding, will instead cause the formation of +2 oxidation state. So our clear answer here is C, while inert pair effect will be for +2 oxidation state, since the outer 2s electrons remain paired and cannot take part in bonding for the lower members. Question 7. Identify the product formed when sodium nitrate is strongly heated. So nitrate of group 1 will be decomposed to their nitrites and oxygen gas. So nitrate of group 1 are decomposed to their nitrite and oxygen, while nitrate of group 2 are decomposed to their oxide, nitrogen dioxide and oxygen. So therefore, since we are dealing with the nitrate of group 1, the products will be sodium nitrite and oxygen, making our answer to be A. Question number 8. The reaction of benzene with bromine in the presence of iron 3 bromide is? So whenever we have iron 3 bromide, it is a very strong catalyst. It causes a hydrogen atom to be replaced on the benzene ring, generating bromobenzene. So the product form will be something like this, and if we have this product form, therefore the reaction is electrophilic substitution reaction, making our option D to be correct. So it should be noted that the benzene ring predominantly undergoes electrophilic substitution due to the delocalized pi system of electrons around the ring. So D is our correct answer. Question 9. The reaction between two species C and D was investigated and the following data collected. We have the experiment 1, 2, 3, and we have the different concentrations and the initial rates. The rate expression is given as, so we want to determine the rate expression. The first thing we have to take note of is get the different orders of the reaction. From there, we can bring out our rate expression. which is going to be rate equal to K, which is the rate constant, C raised to the power M, and the concentration of D raised to the power N, where M and N are the respective orders of the reaction. So in order to get the order with respect to C, we are going to take concentration of D to be constant for two experiments. So if we consider experiment 1 and 2, we'll realize that it is constant for D and varying for C. And how does it vary? If we take 0.3 divided by 0.15, we are going to have 2. Now we come to the rate, we take 4 divided by 1, we are going to have 4. Now we're going to say that the rate increases 4 times when the concentration of C doubles from experiment 1 to experiment 2. Hence, it is second order with respect to C. Now, looking for D, we are going to take experiment 1 and experiment 3, where it is constant for C, 0.15, and it is varying for D. So, we take 0.3 divided by 0.15, we're going to have 2 as well. We come here, we take 2 divided by 1, we're going to have 2. So we're going to say that the rate with respect to D doubles when the concentration of D doubles. So it is then first order with respect to D. First order with respect to D and second order with respect to C. So that our rate expression will be K, concentration of C raised to the power 2 times the concentration of D raised to the power 1. Making our answer C to be correct. So we are going to make more videos on reaction kinetics in the future. Question number 10. In the complex ion given, which is this, state the coordination number and oxidation state of chromium. So this is a complex ion. The first thing we are going to do is identify the coordination number and also the oxidation state. So En is actually ethylene diamine, and the open structure is this, where you have 2 nitrogen atoms with lone pairs of electrons. So ethylene diamine can be able to form 2 bonds with a central metal atom because it has 2 nitrogen atoms with lone pairs. Chlorine can also form a bond, and there are 2 chlorine atoms. It means that they will form 2 bonds. And now, since there are 2 ethylene diamine molecules, they are going to form 4 bonds altogether. Therefore, the coordination number is 6. Coordination number is defined as the number of coordinate bonds that ligands can form with the central metal atom. Now for the oxidation state, we are going to sort out the oxidation state of chromium in this complex. Making this X, we are going to have X plus minus 2 to be equal to the overall charge, which is 1. The minus 2 is for the chlorine. Ethylene diamine is 0 because it is neutral, so that our X will equal positive 3. And to this effect, our answer is B. Question 11. How many lone pairs of electrons are in a molecule of carbon monoxide? So let's draw out the structure. So from this structure, we realize that the only pairs that are not paired are this and this. So it means that a molecule of carbon monoxide has 2 lone pairs of electrons, making our answer B to be correct. Question 12. An element X has the following successive ionization energies in kilojoules per mole. To which group in the periodic table does X belong? So we are going to check these values and we see where there is a large difference in energy as we move from first, second, third, right up to the last ionization energy. And if we check critically, we are going to realize that the large difference in ionization energy is to move from the 4th to the 5th, where it moves from 4,000 right up to a very significant value of 16,000 kilojoules per mole, making a large difference in energy. So the last difference in energy is at the level of the fourth ionization energy, which marks the last electron removed. So the element belongs to group 4, because we're going to count 1, 2, 3, 4 to the last ionization energy before the quantum jump to the next. So we are having A as our option. Question 13. A sample of an organic compound was heated with sodium pellets and dissolved in water. A sample of the solution turned violet with prepared sodium nitroprusside. This indicates the element present in the sample is. Once we see the presence of nitroprusside, it is to test for sulfur in an organic compound. So sulfur is the element present, which will give a violet complex with nitroprusside, making B to be our answer. Question 14. Which of the following compounds is most readily hydrolyzed? So hydrolysis is a reaction with water. So the most that can be hydrolyzed is ethanoic chloride, which is option D, due to the presence of the acetyl chloride group, which is this group that tends to react in nucleophilic substitution with water to form an acid, an hydrochloric acid. So option D is our correct option for hydrolysis. Question 15. Calculate the concentration of chloride ions in a solution containing 100 cm³ of a 0.1 molar magnesium chloride. So we have been given the volume alongside the concentration of magnesium chloride. So the first thing we have to do is calculate the number of moles of magnesium chloride, which equals the concentration times volume. And our concentration is 0.1 molar, and our volume is 100 cm³. Converted to dm³, it will be 0.1. So our number of moles will be equal to 0.01. Now we are going to dissociate this compound, magnesium chloride, so that we have magnesium 2 plus ions plus 2 chloride minus ions. If we look at the mole ratio, we have 1 and 2. So 1 mole of magnesium chloride, when dissociated, will give us 2 moles of chloride. So by simple proportion, 0.01 of magnesium will give us 0.01 times 2, which will equal 0.02 moles. Now we have 0.02 moles of chloride ions, but we have been asked to get the concentration. So concentration will be number of moles divided by volume in dm³. Number of moles divided by volume in dm³. So getting the concentration now of chloride, we will take 0.02 divided by volume, which is 0.1 dm³. And our answer is going to equal 0.2 molar, making our option C to be correct. Question 16. In the periodic table, the elements down a group are arranged in order of. So the main order of arrangements of elements in a group, say group 1, will be in order of increasing relative atomic mass, increasing mass of the elements. As the group is descended, the relative atomic masses will be increasing. So C is our correct answer. Question 17. For the reaction hydrogen plus fluorine to give hydrogen fluoride, calculate the enthalpy of formation of hydrogen fluoride in kilojoules per mole given the following values of bond energies. We have hydrogen to hydrogen and the like. So to calculate the enthalpy of this reaction, it is simply going to be the sum of the energy of reactants minus the sum of the energy of products. So this is energy of reactants, and this one will be energy of products. So hydrogen to hydrogen is reactant, so therefore enthalpy of reaction will equal 436, that is for hydrogen to hydrogen bond, plus fluorine to fluorine bond, which is 158. That is all for reactants. Now for products, it's going to be minus. For products, we have HF and the coefficient of 2. We're going to take the value multiplied by 2 times 565. So the enthalpy of reaction is going to equal minus 536 kilojoules per mole. That is going to be our value, making option B to be correct. Question 18. Which of the following is the strongest acid in aqueous solution? So for the ozo acid of iodine, acid strength increases with increase in number of oxygen atoms. Therefore, we expect the ozo acid with the highest number of oxygen atoms to have the highest acidic strength. So option B is going to be our correct option, because this one has up to 4 oxygen atoms. Question 19. The compound 2-methylpropan-1-ol is an example of. So let's first of all draw out the structure of the compound to see what it gives. So this is the compound we have, 2-methylpropan-1-ol. Prop means 3, and we have 3 carbon atoms. The OH group is on carbon 1, the methyl group is on carbon 2. So it is primary because only one of the hydrogen atoms from the functional group carbon has been replaced by this whole group. This is an alkyl group that has replaced one hydrogen atom from the functional group carbon. The functional group carbon is that which carries the main functional group, which is the OH group. So it is a primary alcohol, making our answer to be C. Question 20. Find the pH of 0.02 molar hydrochloric acid. pH is simply equal to negative logarithm of hydrogen ion concentration. So pH will simply equal negative logarithm of 0.02. Therefore, the pH of the solution is going to be equal to 1.7, making our answer C to be correct. Question 21. Which of the following is an amphoteric oxide of period 2 of the periodic table? So an amphoteric oxide is that which has both basic and acidic properties. Aluminium oxide is one of which has that, alongside beryllium oxide. But aluminium oxide is in period 3 and not period 2. So our point of interest is beryllium oxide, because beryllium is in period 2 and beryllium oxide is amphoteric. So making D to be our correct option. Question 22. Ammonia is manufactured industrially by the Haber process. Which catalyst is used for the process? The catalyst used here is simply finely divided iron, making option B to be correct. Vanadium is rather for sulfur trioxide production. Question 23. Which of the following pair of oxides is acidic? So all the oxides given are group 4 oxide. The only pair that is acidic is carbon dioxide and silicon dioxide pair. So it's only D that contains the 2 oxides being acidic. Carbon monoxide is neutral, germanium oxide is basic, and lead oxide is amphoteric. So the only pair with acid is D. Question 24. Give the name of the compound below. This compound is an N-substituted amide, where the methyl group is attached to the nitrogen atom of the amide. So it is going to be a methyl group attached to N of the amide. So we N-methyl, you count 1, 2, ethanamide. So the methyl group is on this N, so it is going to be N-methyl ethanamide. So if we check, we are seeing B to be the match, N-methyl ethanamide. So this compound is an N-substituted amide. Question 25. what would be the coefficient of dichromates and iron 2 ions respectively when the following redox equation is balanced? So we're going to make sure we balance this redox equation to see the coefficients. So the first rule we are going to take here is to bring out the half equations of this overall redox, bringing out the oxidation half equation and the reduction half equation. So for the reduction half equation, we have dichromate being reduced to chromium 3 plus. So being reduced to chromium 3 plus. And since there is no oxygen on this side, we are going to add water to balance it. And we add a proton here to balance hydrogen. Balancing the atom, we add 7 here, and here will be 14. So atoms are balanced. Now charges are also to be balanced, and to be balanced we'll add 6 electrons here. Now for the oxidation half cell, we have iron 2 being oxidized to iron 3. We add an electron to balance the charge. Now the overall, we combine these two half equations, making sure that the electrons cancel out. And if we do, we're going to multiply all through the second one by 6 and multiply the first one by 1. And then we have this overall equation. So the coefficients of dichromates and iron are respectively 1 and 6. So making our answer A to be correct. So that is it for this video. If you found it helpful, don't forget to hit the like and subscribe button. Until next time.